Hello everyone, it's Dmitry. We on the course Getting Started with Analytics and Data Engineering, and this is lesson 5. We'll talk about Analytics Mindmap. And by Analytics Mindmap, I presume that we will cover only data roles, and the data roles that you might benefit from learning from scratch or like progressions in your career. It's data analyst, like product analyst, market analyst, any kind of analyst. It's BI developer, BI engineer, and there is more technical roles like analytics engineer and data engineer. So of course this might helpful for everyone else who just interesting what kind of things involved in this industry, maybe for HR, maybe for the product manager, maybe for the sales teams, especially who selling analytics products. That would be very helpful. And yeah, Mindmap will start from analytics solution. So this is, for example, our analytics solution. By analytics solution, I instantly imagine the picture of our layers, starting from the source layer, and like with data processing layer, there is storage layer, business intelligence like business layer, there is machine learning layer, and there is technical layers. So it's like very different complementary tools for our solution. So we will explore all branches of this mind map. I already pre-built it to save the time, and I will talk about different things. So the first thing, yeah, you see, it's pretty huge, right? But we'll cover each point. So if we come back to our like architecture framework with the source layer, and source layer, yeah, there some things they connected with each other, some they completely separate. For example, I will talk about soft skills, or I will talk about some knowledge related to machine learning. But here, the first I will talk over the layers and like what come to my mind when I talk about the layer, what you should know. So because you remember for the source layer for layer 1, you have different kind of data sources, starting from backend databases, also known as online transaction processings. But those databases, they could be two types. It could be relational. MySQL, Postgres, the most common choice. They could be NoSQL. For example, MongoDB, one of the most popular open source database, with like public cloud vendors have. For example, the very popular is DynamoDB on AWS, or is Cosmos DB on Azure, or is something similar on Google Cloud. And you shouldn't be expert in especially NoSQL database, because usually for data roles we're using those kinds of database as a source. So if you want to know, for example, how to interact with NoSQL database like MongoDB, all what you need to know, okay, you have the MongoDB database, it has some data there. Your goal as a data person, extract data. So you need to know how you can connect this kind of data, because we know for relation database, you have the host, you have the port, you have password, user, and then you have schema, tables, you can query this, and so on and so on. And we will talk more about this in the model too. For NoSQL database, I'm not going into details, but maybe we'll do some kind in the future, like the projects working with MongoDB as a source for data analysis. Another very popular data source is the application program interface, API. For example, if you talk or many available services like Salesforce, Google Analytics, Facebook, Instagram, TikTok, all of them, even if they're using some kind of database to store their data, they never give access to their database. Instead, they build like layer on top of their storage or database, and they defined application program interface API, like endpoint, and usually it's some kind of URL that you can connect it with your program. For example, you have the Python program, or you can, like, if it's no code solution, for example, I can mention Fivetran or Matillion for data integration. They have a bunch of data connectors. It means you only need to specify your credentials. That's it. But your credential, you first going, for example, Google Analytics, you create your like, you enable the Google Analytics API, you get your service key, or define the way how you're going to authenticate, and then you just take your credentials and input in the tool. And now you can extract the data. But if you start exploring the data will look very similar to traditional database. You have tables, you have columns. For example, if you check Salesforce schema or Salesforce data model, you can find a bunch of tables, like with account tables, or with contract table, customers table, and they have the columns. So those two, they're probably the biggest sources, and very often they especially important for data engineers role, because data engineer building the data integration. Sometimes analytics engineers doing the same. For data analysts, it's good to have, because you want to progression towards like data engineering. But I also will talk one of my lesson about career progression, and talking about people management versus IC, individual contributor. So the next big set is different files, because there are lots of different files in the organization. The most popular is probably CSV. The financial teams or the market teams, they really like spreadsheets, Microsoft Excel, Google Sheets, with some semi-structured data like XML, JSON. Which could be storage things like the shared drive, like Google Drive, SharePoint, Dropbox, or just Box, or many different things, and they have the files. For example, very simple example is the finance budget, right? Someone defined the finance budget for the next year. You won't take it, and maybe you can compare your actual metrics with the budget metrics. Logs, it's also files, but you can tell them they could be semi-structured, they could be more like text-based. The very popular example is access logs or clickstream or we often give the name for the logs is telemetry systems. For example, telemetry systems like computer game. So you play computer games, it generates a bunch of logs. And in context of computer games, we often use the words telemetry. So by telemetry, we mean there is some logs generating and they dumping in some kind of storage. Usually it's cloud storage. And then it could be, for example, then I used to work in Xbox, our games generating telemetry data. It was just JSON files, and they have nested structure. So different kind of events like did user use this weapon, how many shoots they have, how many kills they have, and so on and so on. It's all JSON files, and then you can parse it, extract insights, and learn about user behavior or player behavior. SFTP, quite popular things, especially like maybe 10, 20 years ago. I know still some company using this. It's the same like shared folder before like Google Drive, SharePoint was popular. The cloud storages is also very popular, because every public cloud, and right now most of the modern analytics solution, they host it in the public cloud. That's why in AWS we have S3, in Azure storage, in Azure we have Azure storage, and Google we have Google storage, and they also use the name buckets like S3 buckets on AWS. So that's everything what coming to my mind. Of course, you need to know how you can integrate this, but it's more going to data processing. So the next layer that we want to talk is data processing layer. So the data processing layer, this layer is the thing that when we extract the data, we can do some transformations, cleaning of the data before moving into layer 3, or we can just move all data in layer 3 in the storage, and then after using tools from this layer to process data inside layer 3. So here, first there is two big chunks. It's the batch. It's then you run your job on schedule, so you can run it like once an hour, every 6 hours, and every like 24 hours. This is how usually data warehouse works. Traditional approach, you run it once a day. Like for example, you start at like 2 a.m., 1 a.m., and you want to pick up all the data from yesterday, process this, and load into your data warehouse. So in the morning, when the user comes, they can use it. So right now, with the cloud computing and how things evolve, you can run it way more often, like you can run it even every hour. Less than hour, it doesn't really matter. The streaming is alternative. It means you constantly stream the data. For example, coming back to my example of the game, we started with telemetry approach. First, it was running every 24 hours, so we pick up logs from yesterday. Then we used every hour. So now you can check in your like BI tools what was 1 hour ago in your game, like all the metrics. And then we started onboarding streaming. In my case, I use actually I can add this Apache Spark structured streaming. So the Apache Spark has the library for the streaming. So the most popular probably is Apache Kafka, Apache Flink, and Apache Spark has structured streaming. So I use Apache Spark structured streaming. They call it micro batching because it's like read, I don't know, like seconds or less than seconds delay. But I use this approach, all telemetry logs streaming into my storage account, into first raw data, then a bit of like transformations to like staging, and then we process every hour the fact table. Yeah, for the fact tables, usually by the fact table I mean the table with the metrics. Very often we need use some analytical functions. For example, if you have player or customer, you want to look up like how many, like if it's customer for e-commerce, you want to know how many purchase customer has over all time, right? And then you need to do some kind more logic. For example, it's the marketing logs. You want to know what was the customer session, and maybe if the customer session on website was like 1 hour, and you stream events like, and you can see only like I don't know, you have window 1 minute or 5 minutes, whatever, you're not able to see like the full information to run your window analytic function. That's why usually you do append mode, then you stream events and you can append, like stack them over the time, and then you have the batch to process actual like metrics, especially complicated. So for the batch, I've added also a bunch of things. First, it's ETL and ELT. So we'll talk about these on layer 4. The difference where transformation is happening. It's either in the tool itself, or you outsource this to your storage platform. Then orchestration tools like schedulers. Very often, like especially if people using popular tools like dbt, you want to orchestrate your jobs, but it means basically you want to run the jobs on schedule. So Airflow, Prefect, the Daxter, free, the most popular open source tools. In other terms that good to know and important to know, what is DAG, direct acyclic graph, because Airflow has DAG, dbt has DAG, and many tools use this concept. The idea is a dependency of the job. So if you have multiple jobs, you want to execute them in order, and there is some dependency, so the DAG will highlight all dependency. And for example, if job C requires succeed both A and B, so your DAG will be A and B running together, and then they coming to the C. So that's the DAG. It's just visualization of your task. So ETL, ELT job, it's actually then you schedule, like we just use the term like ETL job. The pipeline is the same as a ETL job or the same as a DAG, so it's your transformation. So if, for example, you extract data from Google Analytics, you do some kind of transformations, you maybe merge it with another data, blend with another data. It could be one big pipeline, or it could be just one pipeline. For me, it's synonym of like ETL job. So some tools that coming to my mind for ingestion, because first of all, for the ETL tools or data processing tools, we have two kinds of tools. One tools that can do everything end to end, and for example here I highlight like Matillion ETL, or you can think about legacy tools like Informatica or any other like from Oracle, IBM. They can do end to end, and they have connectors to the data. They have capabilities for transformations, orchestration, everything. So you don't need anything else. In other tools like dbt, they can do only transformation, And here I highlight what's transformation, right? We can use dbt, mostly with SQL, the Spark. You can use PySpark, Spark SQL, Scala. You can use raw SQL in your data warehouse or data lake or lakehouse. You can use the pandas. And alternative could be probably worth to mention is Polars. So it's way faster than pandas. I personally didn't yet use Polars. I work either dbt or Spark. So for the ingestion tools, I highlight Arbeit and Meltano. That's open source tools with a bunch of extractors. They semi-ready, but sometimes if you need something out of the box, you probably need to go in the source code. And you also need to weigh how you're going to host it. Usually you host them in containers. And we'll talk about containers too. So, and in Model 0, I already talk about containers. Fivetran and Stitch, those tools cost money, but they kind of like same idea. For example, Fivetran is software as a service. You pay for what you use. Okay, reverse ETL is another term. Assume you have your storage layer and then you want to extract the data. So that's why you use ETL. Streaming we covered. Also, I would highlight there are open source tools, there are commercial tools. Also, there is cloud and on-premise tools, and low code, no code. So low code, no code is like Matillion is no low code, no code tool. Fivetran the same, but on the other hand, the tools like dbt or Airflow, they code tools. And usually open source tools, they with code, commercial tools without code, and they have pros and cons. It depends on the case. The big thing related to data processing is data quality, because then you have your pipeline, and also you might have lots of interview questions. So then you have your pipeline. How you can ensure the quality of the data. So it's freshness, the data is fresh. You have unique key, avoid duplication. For example, if you calculate your revenue, it should be in the given range. Maybe you have column that shouldn't be equal null. Also, you need to know what's the null, because you have empty space and null, and they're different. So you have list of the values. Also, integrity check. For example, if you have primary key and foreign key, and I will talk about this in database theory in Model 2. And some tools coming to my mind. The most popular is the Soda, dbt testings, and I forgot to mention is Great Expectations also. But it looks like Great Expectations somehow not that popular right now. There was also one tool very popular for Spark. I think it calls DQ. But also, I don't know, not hear a while about these tools. Another term quite new is a data contract. So basically you defined what your expectations of source layer data, then you load and process it with processing tools into layer 3. For coding, how you can interact, the most popular SQL you must know. The Python also, it's like default standard, but you don't need to, if you don't know SQL and Python, you don't need to learn both at the same time. Master the SQL first, and then you can come to the Python. I also will spend some time later in the models to Python to show the resources and the most important thing that you should know. For example, usually for working data, you don't need really to build the classes. Usually the functions is enough. So sometimes you can work with Scala. In Microsoft world is C#. This, I don't know what is it, so I can just delete it. Okay, we're done with data processing tools. The next one, here I also want to talk about storage layer. So for the storage layer, it's starting from data warehouse. So Snowflake, Redshift, BigQuery, Synapse on Azure, or is ClickHouse, DuckDB as modern open source alternative. And those probably for the most popular. For data lake, there is tools for big data. And for big data, for me, it's not the size of the data, but actual tools work. And the tools usually related to the Hadoop ecosystem. And I will talk about history of the industry, and I will talk about like Hadoop and some tools about Hadoop ecosystem and how things evolve over the time. So there is Spark tools, and there are a bunch of, there is open source Apache Spark. There is also like vendors, Databricks, Glue, Synapse, Dataproc. So Databricks by itself, Glue on AWS, Synapse on Azure, Dataproc on Google Cloud. For example, Hadoop, there are different options. For example, HD Insight on Azure, Elastic MapReduce on AWS, Dataproc on Google Cloud. So Hive, initially Hive was like SQL interface for your Hadoop, but now we use Hive as a metadata, meta store for all your big data, data lake things. There is also serverless, very popular right now, and because you can find like Spark serverless or Amazon Athena is the serverless SQL engine on AWS. There is Synapse serverless Spark or SQL. So yeah, serverless is and Elastic MapReduce on AWS also serverless. So it's just alternative of traditional way how you host the things. There is Redshift serverless, and probably there is something Snowflake will come up with serverless. So everyone is doing this, and it saves a lot of cost for you because you don't need to run your servers. You only pay for what you use. That's the idea. And data lake files format, the most popular is like Parquet, Avro, and RC. So for data engineers, good to know the difference, but default one is Parquet. So just to know what's Parquet. Lakehouse approach, that's a kind of like mix of data warehouse and the data lake. And usually it ties to the tools that can sit on tops, like the Spark, Hive. Usually it's the Spark. It could be like Amazon Athena or some serverless things. And you have maybe you have the Parquet, but you have like different format like Delta, Iceberg, and Hoodie. And very popular tool that have everything inside is Databricks. So by default, it's Delta Lake you build with Databricks, but you can choose any other options. So, and two more things is public tools, or like where you can host it in the public cloud on premise. And on premise, it's probably would be like Hadoop and HDFS, and some companies still running in this way. And also, again, open source and commercial, and the same is applicable like low code, no code things. Performance optimization is very big thing, and because you usually query the data, you process the data. Sometimes it can be slow, sometimes could be error like out of the memory. Oh, by the way, right now is quite popular things is Trino. So maybe we can add the Trino as a tool by itself. And for example, Amazon Athena is a kind of similar to Trino, but it used called like Presto, and then it was took by AWS, and they use this open source product to build their service Amazon Athena. And I think it's quite popular tool and worth to be here. What else? Performance optimizations, yeah, is the big thing. So you should think about compressions of the data. You should think about partitions. What are the things you can do, like, or it could be sorting, could be cluster key, could be indexing, or many, many things. The partitions is a big thing here. How you're going to partition data. And it's every kind of those storage systems, because usually it's distributed systems that can process huge volumes of data. I specifically not use the word big volume of data or big data, avoid this. So like huge volume of data, that's why because your goal is to decrease amount of data that you're gonna scan, and partitions help this. Yeah, and there are maybe some optimization techniques like low level, especially in the Spark or Hadoop, but those like is good enough. Here I also have the data models, because then you build your data warehouse or like data lakehouse, you need to do some kind of data modeling. So dimensional modeling from Kimball, the most popular, and here are the terms, and it's actually also a good question for interview. The terms like slowly change dimensions, star schema, snowflake schema, normalization and denormalization, breach table. So those terms is good to know, and you could be asked on any interview about them. So Data Vault, um, Data Vault is another thing. It's alternative for your dimensional like star schema model. There is also a term like third normal form that was offered by Inman, and it's different from dimensional modeling. And usually, like company can use or engineers can use third normal form in the middle of data warehouse, and then they can build like dimensional modeling. I also want to highlight operational analytics. So it's the different term. If data warehouse focus on the historical data, operational analytics will focus on data like for short term, but usually it's raw data, and we can use tools like Elasticsearch or Azure Data Explorer, also known Kusta, or Splunk, Datadog, Prometheus, Grafana, Kibana. Kibana is more like for UI. They're open source. Prometheus is open source. Elasticsearch is open source. Kibana work with Elasticsearch. Logstash, we work Elasticsearch. So yeah, it doesn't really matter how they work. I just name a few tools here. The idea it's very different from traditional like data warehouse or big data analytics, whatever term you like. Because operational analytics, it's usually stream events. Like for example, you can stream telemetry data from the game, from the clickstream logs in real time in Elasticsearch or another tool. For example, Microsoft Gaming using Azure Data Explorer for streaming the data in real time, and then like operations teams or the manager, they can look to raw telemetry that was happened like, I don't know, minutes or seconds ago. And if you have any kind of issue or failure, you can instantly dig into the problem and find the root cause. And also I know that, for example, Azure is using Data Explorer to power all telemetry for Azure platform itself. And this is not suitable for traditional analytics. So you don't do much of aggregations, you don't look like year-over-year metrics, and so on and so on. You don't load usually business data because it's specifically for this kind of like telemetry systems or log systems. And last term that we can highlight here is data mesh. It's only applicable for the huge organizations. And where in organization they have just one like data warehouse or lakehouse, you probably don't need data mesh. But then you have multiple teams. They run, one team is running, I know, Snowflake, another Databricks, another team run Redshift. They have a lot of data assets. Then you should start thinking about how you're gonna do this kind of like union all different sets together. Yeah, the next point for analytics solution, like the next chain, is the public cloud. And you might know that, from my video, that all the things that we build for analytics, they usually like 90% nowadays hosted in the cloud. Some companies trying to avoid this, and it's even cost efficient in many cases. But for public cloud, I will have the Model 5 because I also teaching in University of Victoria for cloud computing fundamentals for last 4 years. So that's why I know like the theory behind this, and I know how it ties to the analytics. So 3 main public cloud vendors: AWS, Azure, GCP. Then you have the storage buckets. I just highlight what's the most important, right? How you store the data, like the storage buckets. Then the virtual machine. Then you have permission security, also known identity access management, networking, virtual network, subnet, firewall, security rules, and so on. Cloud service models, infrastructure as a service, platform as a service, software as a service, cloud deployment models with public, hybrid, private, but in our case it's only public, and also cloud shared responsibility models. So those, and of course they have like hundreds of different services. You may use them, you may not use them. They're also offering you like the ways how you're going to deploy it. So many things. I just highlight like the bare minimum that you should know before doing your solution. Yeah, we finished with the public cloud. We talked about data processing layer. They talk about storage layer. We could talk about source layer. The next layer is a business layer. And here I want to highlight the business intelligence tools. And I will have model 3 about business intelligence tools, but we can start from simply some tools available with client, some without client. By this I mean, for example, if like we take Power BI desktop or Tableau desktop, that's the client, right? You install on your local machine, you do the work, and in other tool you can do like Looker, for example, or AWS QuickSight or Google Data Studio. They don't have any client, so you work in the browser. And I highlight like some tools with some tools. The most popular BI is Tableau. It's not could be not like we don't need the yeah, I think that's right. There is Power BI, Looker, Superset. It's open source, Metabase open source, Redash open source. There is like Mode, there is Sigma. There is so many different tools. We can have Mode, Sigma. I know Sigma on this, and maybe this. There is Domo, TIBCO. There's so many different tools. Yeah, we'll talk more about Model 3. Then for BI tools, I often give importance to administrations. For example, if you have Tableau, Power BI, how you host, how you sharing your BI dashboards or your work, and usually it's through the service. So, and that's why the jobs that related to BI developer or data analyst who manage BI server, it's very often like you need to add the users, you need to like tune the performance optimizations or the security, or even you can install actual like deploy BI server and admin it, right? You need to like install the patches and many other things. So like typically you're responsible for end to end, and this is very good if you thinking about data analyst role or BI developer role. So this is where you can go deeper because it gives you competitive advantage. So also the tools, we can split them self-service and enterprise tools. And self-service tools, they like Tableau, Power BI, you can quickly, like business users, they can start and doing it themselves. For enterprise tools, it's more like traditional tools like MicroStrategy, SAP Business Object, and actually Looker I consider as enterprise tool because it has the semantic model, like the big model that you can build, and then people can take chunks of it, but it still have the self-service capabilities. The customer experience is important. You have documentations, you can run surveys, you can have office hours, onboarding trainings, the data visualizations, the big topic, the semantic model or your data model for your BI, dimensions and measures, reports and dashboards, pivot tables, and sometimes mobile cloud dashboards. All of these we'll learn and cover, but those are the topics that are important to know about Layer 4. Did I add the documentation? Yeah, I add customer experience documentations. So now we can talk about a bit of Layer 5 for machine learning. It's not our primary goal to learn machine learning here, and maybe I put this in the end, and maybe someone else to add to Surfalytics a bit more like deep knowledge for machine learning. Currently it's out of the scope, but based on my experience, it's very helpful for me to get quickly context of machine learning projects, because now almost every organization have like some data science, machine learning, AI initiatives. So if you know the basic and fundamentals, you can quickly see how you can add the value. So there is terms like AI, what's artificial intelligence, and machine learning subset of artificial intelligence, deep learning subset of machine learning. So then you have like supervised learning and unsupervised learning, and you have like classifications, regression type of models. For unsupervised, for example, it's clustering. With machine learning operations, MLOps, and the tool I know, for example, MLflow. Some popular package and tools that using in this field, for example, AWS has SageMaker, with scikit-learn library quite popular. I think it's so many different things available here. You can build like huge mind map just out of these or any of those points in the machine learning. Some business use cases: recommendations engine, customer segmentation, product classification, security. Right now you have lots and lots of tools available for generative AI that can improve productivity of developers, or better build better documentations or chatbots that basically overall improve their performance and outsource routine work to AI. Statistics, I don't know, it should be part machine learning. I don't know where it should else I put it, but this is probably the basic things that you need to know and from what you can start. So the next layer is layer 6, technical layer, complementary. So here I'm talking a lot about engineering excellence, and DevOps basically it's part of engineering excellence, but what in this branch we see? The version control systems like Git, GitHub, GitLab, Azure DevOps, Bitbucket, so you should know how to use what's continuous integration, what's continuous deployment, code reviews and why it's important, pull requests, merge requests, the containers. We already covered the Docker, the containers orchestration, examples Kubernetes, Azure Container Service. On AWS, it's Elastic Container Service. With also registries where you store your images, all those things, right? It's important. What else we have? Infrastructure is a code. Terraform is it was open source, now it's still open source, but I think it changed for organizations. But every tool, every public cloud has their own approach how to manage this infrastructure as a code. Also with linting, and it's also in pre-commit. I don't know, should we add the pre-commit somewhere? Maybe here I can just add pre-commit, but by this I mean that maybe not here, maybe linting, and just will add separate. I usually like to add pre-commit and linting for all my projects, and this is a good things to start when you join new organization. Engineering excellence is about this, how you produce the quality code. The data catalog is also how you gonna make sure that your assets, your dashboards, your metrics, your data models accessible for end users, how they know there's the data coming from, what transformation is happening, and it's also could be part of data governance. But data governance is more like practice. So, but data catalogs, it's more like tools. That's why I specify some of the tools: Alation or Databricks Unity Catalog, Azure Purview, or open source tools like Data Hub and Open Metadata. The cost optimizations now is the big topic. Right now, everyone count the money, trying to reduce the cost. Our organization struggles to make their goals for revenue. That's why cost optimizations is big topic. And public cloud usually very good to give us insights about our spending, and we can trying to see how we can optimize resource. Like this, for example, data processing and the storage optimizations can save us money. So many different things. What else? So the next topic, I think I'm done with the layers. The next topics I want to talk about roles overall. So we have non-technical roles: data analyst, BI developer, visualization engineer. It could be product analyst, marketing analyst, could be BI engineer. Sometimes it even could be like data developer or SQL developer. The technical, here I put the BI engineer in technical, and honestly, it could be in both. If you administrate like BI server, it's probably technical because you need to know a bit networking, how to use the Linux systems. Oh, and here we also forgot to mention about CLI and ID, right? It's what I add in the model 0. So the technical engineering roles: BI engineer, analytics engineer, data engineer, legacy roles like ETL developer, big data developer, Data architect, very similar to data engineer, um, data scientist. I don't know if it's the right place to put here data scientist because here we can also then add like ML engineer. For non-technical roles, I also know, for example, in Amazon we have like research scientist. I know the Facebook has this role. This is non-technical role, but usually the people who work in this role, they have like some kind PhD. And there is also like maybe we need to highlight like people management roles, but let's add. And here we can add, for example, head of team. This could be team lead, or it could be just manager, senior manager of the, and they have different titles like data engineering, analytics, or could be director role. Of course, or it could be like probably VP role, but it's very different scale of things. But they all also related to the analytics, and those folks, it's one like how where you want to grow, right? And here just I highlight the people management is alternative to individual contributor. So in the last thing here, or not last, uh, I have two more things. One is the soft skills. So I highlighted writing, mentoring, teaching, coaching, and leading. And leading by example, that's it's very important things. So how it's very good things to mention that on the interviews that how you write the documents to collaborate with another teams. You have the examples of documents, what kind of documents exist. Mentoring, how you mentor junior people, how you teaching coaching, and maybe how you lead the projects. The last thing here I have is domains. So I highlighted domains because all of these that we covered, they should be tied to some kind of like business domain. And especially if you start your career, you need to take one domain and understand it better on like on the business scale. What is it and how it works? So the most simple one, like the simplest, is digital marketing. And here you can know about some different digital marketing metrics. You can know attribution model, source channels, and also subset of this is you have mobile applications, what kind of metrics. Because then we talk about domains. The thing is important for us, what like top 5 metrics we have there and how we can calculate them, what kind of data we have for source, because for digital marketing you have one set of the source systems. For finance you have another set of the data, and so on and so on. So customer analytics could be part of anything. I just put it individually. The use cases like churn rate, retentions, cohort, A/B testing. The book I always promote to talk about domains and the metrics is Lean Analytics. So this covering really well all the topics. So e-commerce book or e-commerce domain is good, like online shopping. Amazon, for example, is e-commerce, or like any kind of online shop is e-commerce. And also it could be just the commerce. Then it's offline shop. How you gonna like do analytics for online shopping, right? The health industry. Also, the rest could be split for enterprise and startup, like because the how you're gonna work in startup, it's one way of working. How you're gonna work in enterprise with lots of bureaucratic is different startup. So I think that's basically it. And all of those topics we're gonna cover from my course or from my projects or from my like different videos that I usually produce about jobs, about the market. So these many things that we're gonna learn. So